Facebook, like and subscribe, and click on the link to the Patreon.
Can you imagine if you had to watch an ad before you can watch?
Oh, if you get ads on your videos, I will actually just go.
Of course,
full time.
I don't blame you. I don't blame you at all.
Watch only
That's
on
what I was
Instagram.
gonna say. I wish I knew about that during like this entire semester. Sometimes all their lectures.
I show Speeds reacts to Walrus me.
All right, guys. So I kind of have this up here just to make it quick. I said I was going to maybe make a handout. Obviously, I didn't. So this is just something quick to kind of reference to help you formalize what you want to go over. So it's of course it's wide open again.
Can you do an example of Newton's method? An example of Newton's method?
Oh, Newton's method. Okay. So the funny thing is, what happens all the time is we go through a derivation of something, and people kind of forget. Once you've got the result written, it kind of hides the idea of it for damn sure. Because I don't know, who remembers Newton's method? Let me get it started. Newton's method. Who remembers? Sorry, I'll make us go one more step here.
X n over.
Oh, so
X n
X
times,
divided
I
by.
think it's n equals 1. No, derivative of f. I'm forgetting so much right now.
Yes.
Doesn't that, that's what we do with LOX?
I'm sorry, I couldn't hear. There's too much. I don't know if you noticed all the other things coming out. All right.
Sorry.
And I don't know, you know, you guys, I don't know what your teacher makes you memorize or anything.
I remember the formula, but I think we call it something different.
Okay. All right. I'm more you. And this came from, this is very, very, it was insanely simple. If you have a decent first guess for what this is, and you make the tangent line and you find the intercept for that tangent line, it will be closer to the real answer if two things. If the function is relatively well behaved, like it doesn't go crazy, and your first guess is good enough, right? If my first guess was over here, the tangent line would have taken me back here, that's really far away, right? Okay. Does that make sense? So again, there's what we end up with, which doesn't look anything like where it came from, right? You totally lose the idea once you get this thing simplified. So now it's just, if I give you a function, I don't know, so I could give it to you like this. What do you got, Jeff? Cosine x equals, you can do it, buddy. X minus. Right, so two things. We have to figure out what f is, but the way it's written, it makes it easy to get a good first guess. Because how do I get a good first guess? Graph it, right? And if I figure out f and subtract, I get this function. I don't know how to graph it, but I know how to graph cosine, right? What's cosine look like? Starts at 1, and it goes, Woo, look at how gross that is. That's gross, isn't it? That's really gross.
Disgusting.
Yes, I know, yes, disgusting. What's wrong? What is this roughly for cosine? When it hit 0? Pi halves. And what's pi divided by 2 roughly? 1.5. Right? Are you guys kind of with me? So again, so many times in this course, you have to make a rough sketch. And again, I don't know how, you just need a rough sketch. And what pre-calculus is supposed to do is to put you through the graphing hell, so that when you just need a rough sketch, you go, oh, thank God, I just need a rough sketch. I can do that shit. Because normally I'm used to, you know, being really detailed. Cosine x, this is it. This is like 1.5 roughly. It's 1.57, who cares? Not negative, but approximately. And then x minus 1, of course. What is it? What's its x-intercept? 1. So it goes like this. So what is a good guess for where they meet? 1 point something. You know, let's say 1.4. Let me stop for a second.
So Newton's method is calculating where the two functions meet.
Yes. Well, I mean, that's what it could be used for. It is directly used to find the x-intercept of a function. How the shit does that relate to this? Well, what function do I want to equal 0? I just subtract, I just move stuff to one side, right? Which way do you want to go?
Move the x minus 1.
Sure. All right, so I get cosine x minus x plus 1 equals 0. So this must be f of x. That's the function that I want to make 0. So Newton's method's job is to find x-intercepts. So how does it relate to this? Well, if you make this, no, I know I want to make this function 0. Oh, I want to find the x-intercept of this function, right? So what do I need to feed this dude? Well, we got x1. What else do I need to feed this dude? Derivative, right? So I've got this. I need this. So what is f prime? Negative sign. Minus 1. 11. Of course, the 1 goes away. Yes?
Why does where they meet relate to the x-intercept of the whole function?
So again, if these two functions meet, then the function that is the difference of the two must be 0. So this function, 0, means this function, x-intercept, which is what Newton's method does.
Then if they don't meet at all, then there's no problem.
Yeah, if I gave you an equation that never actually had an answer, that the two functions never met,
Yeah.
Newton's method would die, right? There's just no answer. I like it. I'll do that, and you just fill that in real quick. Just get it. All right, so now I just, and again, I'm going to say this a lot. I don't know how Christina does it, but now, if I wanted to do specifically x2, that would equal x1 minus f of x1 over f prime of x1, right? So this would equal 1.4 minus cosine of 1.4 minus 1.4 plus 1 over negative sine of 1.4 minus 1. Now this, why is this not generally useful? I could get x2 from this. I could get x2, but I really don't feel like doing this over and over.
So to do it generally, you just put in one variable.
Yeah, so instead of getting the specific thing, you say xn plus 1 equals, so the next thing equals the answer minus cosine of answer minus answer plus 1, right? Wherever I see an x, I'm going to put answer over negative sine answer minus 1. And of course, the step before this, you would have put, in your calculator, you would have put 1.4 enter. So let's try this out. Okay. I don't know if this is what you guys did, but let me turn this technology on. And everybody pray to the God of technology. You have to sacrifice an Atari or something.
No, not the Atari.
Yeah, it's an Atari. Sorry, bro. It's what it demands. All right, while this thing is warming up, think about the next topic you want to talk about. I feel like I'm interrupting. Sorry.
Yeah. Can we go over implicit differentiation?
Oh yeah, we'll do that next.
Yeah, I have 3 questions.
I forgot
One of
what it
them is
was.
maths, one of them is
Okay.
optimization, and one of them is intervals, because I suck at all of them.
At what? Integral? Oh, I can do integrals.
So which section is this about? We're talking about, we think we may have skipped this section because, which section is this about? Because we think we might have skipped.
I think it's 4.8.
Optimization.
Does that sound right?
Yeah, we skipped 4.8.
Oh, you skipped 4.8. I'm sorry. So this is not very useful, but
It's interesting.
that makes me a little sad. But
It's interesting.
you know, I skipped some stuff too. So, but not this. So guys, here's how this works. 1.4 enter. So So now that's in memory. And some of you guys have no idea what this stuff is, I understand, but Newton's method is just so flippin' cool because it's an immediate application, and it kind of explains exactly what the stupid calculator does. When you say, hey calculator, what's the x-intercept? Does anyone wonder how the hell it does it? This is pretty much how it does it. Now they adjust the function to kind of be careful about certain situations. So, and I reached out to them and said, hey, can you show me the adjustments I want to tell my calc class? And they said, you might be from HP, you spy, get away. Basically. So I'm like, all right, sorry. Anyway, 1.4 kicks us off. Now that's going to be in this memory spot. So then you would do, somebody help me out, answer minus, what was it?
Answer minus
Cosine.
parentheses cosine answer.
Cosine answer. Hold on. So, thanks so much.
Minus answer.
Minus, there you go, somebody. Okay.
Plus 1.
Plus 1
Over.
divided by
Negative sign.
negative sign
Answer.
answer
Minus 1.
minus 1. And now if I hit enter, there's the next best, better guess, right? So now it's going to take that answer and redo the whole thing. So it looks like I can bank on 1.28, right? You see how it's changing less now? And now I bet you it's not going to change at all. Yeah. All right. And real quick. So you guys got that? 1.283 blah blah? 2834? Yeah. So if I hit y equals, and I put in here, what was it, cosine x?
Yeah.
And what was the other piece?
X minus 1.
X minus 1. And I graph this. Woohoo! And I say, okay, calculator, where do they intersect? And you see how well, let's see, first curve, second curve. Look. Right? Oh, look, okay. Is that all right? Is that enough? Okay. And I'm sorry for those of you that didn't talk about that. That's fine. So the next thing I have a request about is implicit. Why is it called implicit differentiation? Anybody remember? What's the difference between implicit and explicit? Say again? Yeah. So I always remember National Geographic, lion kill something. Back in the day, it would be behind a bush, right? That was implicitly. Now you'd see like a full on. That's explicit, right? You always hear about explicit gore, explicit whatever. That's in your face. Implicit means it happens behind something. So implicit because I have y, I just don't know what function it is. Okay. So let's start off nice. What if I have, what do you got, Jeff? X squared y plus e to the y equals 3. Can you solve that for y? I'm not asking you to because you can't. Right? You not solve that for y. But if the instructions say find dy dx, now if I could solve it for y, that would be easy. That'd be chapter 3 stuff, right? That'd be early part, chapter 1, when we first looked, bam, no problem. But I can't solve it for y. Okay. And again, remember, I did this yesterday, but not yesterday, but you know it. If I had sine x to the 1/2, what is its derivative? Good.
Or cosine.
I'll just do this. Prime. Right. Stay with me. What if I had 3x squared minus 7 to the 1/2, and I want to know the derivative? It would be 1/2 in front of stuff to the negative 1/2 times the derivative of stuff. Right? So it doesn't matter. I don't care what function I put in here. Isn't the first step always the same? So then I say, what if it was y to the 1/2? And I take the derivative with respect to x. That would be 1/2 in front of stuff to the negative 1/2 times derivative of stuff. So all implicit differentiation is doing is capturing what I would do if I frickin' knew what y was. Y is a function of x. Chain rule comes into play. That's all it is. So what do I have to use here? Good. So do the first piece. 2x times y plus x squared times y prime, or dy dx. Right. Plus this guy. Good. So the e to the y times the derivative of the inside. So effectively, yes.
Can you rewrite the y to our derivative thing, like dy over dx?
Yeah, sure. Doesn't matter which way. That's literally all it is. It's just a choice. It's either y prime or dy dx. And of course, I'll do the other side, so I do something. Good job, Jeff. So this one's now the calculus is done. Now it's algebra. Dy dx is a variable.
Equals 0?
Yeah, because the derivative of 3. Yeah.
Oh, okay.
Whatever I do to one side, I have to do to the other side. I took the derivative. Good. And that's one of the easiest mistakes to make, is to forget the other side. And now it's algebra. I'm going to solve for dy dx. So what do I want to do?
Bring over the negative.
Yeah, anything that doesn't have dy dx, get rid of it.
Factor out a dy over dx.
And now I can take this out. Right? And that's why I get everything that has the variable I want. I get it all on one side, so I can take it out and I can divide by the stuff I don't want. So now I'm going to divide by x squared plus equals 1. So then I get dy dx equals negative 2xy. What if you do all this work and then you realize they asked for dx over dy?
You just flip it.
You just flip this shit. That's all. It's so beautiful. Literally, if I started from the beginning and I thought dx dy, when I end up, I would get the exact reciprocal of this. It's almost too nice to believe. It's kind of cool. Yeah.
When you write down on a test, like say you were solving for dx dy, and you didn't read it right, you just flipped it at the end, would we get marked down?
No, you're fine. In fact, I love it. A little tear. Because dx dy is weird. Because we're not used to thinking of y as the variable and x as the function. So we can, so I would, if I were to be honest, I would do this, and then I would just flip it. And if your teacher has a problem with that, that's their problem, to be honest. I mean, to me, the more you understand, the less you have to do. That's a nice way to just, bang, get what dx dy is. Now, of course, every teacher has their own restrictions, so just be careful.
And then there's like a second part to this problem, right? We have to like plug something in.
Yeah. So if I wanted to know the derivative, what do I have to do? Like in the past, if I want to know the derivative at x equals 7, that's all I had to tell you, just plug 7 in. But now what do I need? Do I just need an x value? I need a full point, right? So I have to figure out, let's see, 0, no, that doesn't work. I don't know if I can come up with a point on the fly here. It's a little gross. Can you guys imagine? It's a little weird to come up with a point that works.
Yeah,
All right.
we need a
Thankfully. But if they give you a point 1,7 or something, you just plug a 1 and a 7 in for x and y.
That gives you the derivative of y, even though we don't know what explicitly y is.
So this function could look like this or something, right?
Oh.
Who knows?
Okay.
There's not a function, sorry, because this is bad. But this relationship could look like this. So if I want at this point, then I would find this, I could find that tangent line by doing what we just said. Dy dx would be m. I could use the point that I was given to make the tangent line, and it would be the tangent line that represents the direction your little roller coaster is going, if this is a roller coaster, right? Maybe?
Oh, wait,
How is it that for you?
so dy dx is m.
Dy dx is m.
Okay.
Yes. As always. So I know the question was was good, because you're like, how much changes if I have this? Not much. If I plug a point in, it still means m. I can still get y equals mx plus b. It would just be attached anywhere at the point I have to use. The tangent line would be attached. Is that all right? Okay. So you asked about it, is that okay?
Could we do some optimization?
Optimization.
Yes.
Let's do two types of optimization problems.
Yeah, I gotta write down.
Let's do.
Yeah.
I don't know.
The boat moving in the night goes to what?
Yeah.
The change.
Boats in the night, exchange
In the
places.
ladder, I kind of understand that one with the x squared plus
It's anxiety fuel.
Like a bit of excitement, you get one
y.
Boat moving in the night. I don't know that one.
Yeah. Existential dread.
Differentiation. No, what's that called? Impending doom.
Yeah.
No, it's not derivative.
Oh, well, this should be interesting.
No, it's.
Alright. So, guys, let me go over some of the basic, guys, let me go over some of the more fundamental types. You've got this shape lives inside this shape type, right? Like, find the maximum area of a rectangle that's inscribed in a ellipse, right? You've got the more straightforward ones. Here's a profit, find the maximum or minimum, whatever. So those are the easy ones. You've got the, how do I say this? You've got the ones that are like, find the maximum volume given a certain surface area to work with, right? Let me see, what else you got? Oh. Yeah, you got the basic ones like the farmer with the fence, right? Sometimes there's a lake that he doesn't need a fence on.
That's drive circle stuff.
The one I was looking at,
The guy with the bunch of watermelons.
guy with watermelons?
Oh, you know, the math board problems, like.
I know what's going on.
Fence.
All right.
James found that guy.
Actually.
So, no matter what the situation is, if you see it says find the maximum or the minimum, blank. Your focus at first, how do I find the maximum or minimum of a function?
Take the derivative.
Take the derivative,
Find a critical number.
set equal to 0, right? So if I wanted to find the minimum cost, I first have to get a what function?
Function of cost.
A continuous.
Cost function. You have to get a cost function, and then you can attack it. Once you create the function, the steps afterwards are always the same. Take the derivative, set equal to 0, find the critical numbers, blah, blah, blah. Yes? Right? So the whole reason these are gross is because they are true word problems. You're not given a function to work with, you have to construct it. That's always hard. That's what's called modeling. Trying to model the real world with math equations. Right? So let's try this one. This one looks funky-della. 76 out of the book. So I want to make a rain gutter. It's going to go around the outside of a house. And it's 30 centimeters long, but I just take the ends and I flip them up, right? Now this has some length to it, but I'm just doing a cross section. Are you guys with me? So it started off 30 centimeters long, and then I just flipped the ends up. So this is 10, this is 10, and this is 10 centimeters. So the question is, what does this angle have to be to maximize the amount of water it can hold? That's the question. So what are you trying to maximize then, specifically? Volume, true, but if I maximize the cross-sectional area won't then maximize the volume because it's just times the length. You guys with me? So I don't have to worry about the length of this because if I can maximize the cross-sectional area, obviously that'll maximize the volume. You guys, what's happening up there? If I have this shape, that would mean like putting this to be 90, right? Wouldn't that make that? Well, let me make it open on the top. Right, that would be a gutter like that, yes? If I just flip them up to be 90 degrees, yes? It would be this area times this length, right? If I made it, if I put them in like this, which would be really stupid, yes? Would you want your rain gutter to go like that? So it's like, you can't even get in here, right? But that's an option, I could do that, right? And I still have this. And would it still be the area times the length? Yes? So aren't I always just multiplying by the same number? So does it matter what that length is? No, it matters. If I can make the area biggest, that automatically makes the volume biggest. Are you guys with me? So I don't have to worry about volume. I can just keep this 2D. So, all right, some of you guys are still looking at me like I'm crazy, but I'm going to keep going. Okay? Now, who does not like this problem, and why? What's the worst part about this problem?
I don't like angles.
Okay, good. I love it. What shape are we working with? Trapezoid. What's the area of a trapezoid?
Or no, you can like split it into the triangles.
So what's the area of a triangle? 1/2 base times height, right? 1/2 base times height. And here there's 2 bases. So what do you want to call this base here? This base is easy. This base is 10, yes? Plus, what do you want to call this base?
DB.
Who?
Oh, yeah, never mind. But the D changes, like that's.
You know what, let's call them terms.
By the way, why is this not 30? Because
Because
this is 10. When I push it up, that's not going to be 10, 10, 10 anymore, is it? Okay. It depends on the angle, so now you see how the angle is going to come into play. Okay, so what I'm doing, I really want you to understand. They want me to maximize the amount of water. Okay, that would maximize the volume, but the length is the same. So maximize the area. So now my focus is make an area equation, because then I can attack it, right? So that's what you first identify with an optimization problem is what do they want me to optimize? Can I make that equation? Yes? So let's call this B for base. That's crazy. So now, does the problem give a shit about B? The problem cares about what? Nobody's looking at this. This is number 76 on page 341. How should theta be chosen so that the gutter will carry the maximum amount of water? So which variable do I need information about eventually? Theta. I want to know how much to bend this metal, right? Okay, so do I care about B? No. All right. Is there a relationship between B and theta? So let's see.
no, yes, kind of.
Not kind of, exactly. Isn't this 2 triangles, yes? Are the triangles different?
So there's.
Because I'm assuming I'm bending them the same amount, yes? Okay. This is 10, yes? This is 10. So what is B? It's 10 plus. Again, the important thing about any problem like this we do together is to understand what motivated me to do the next step, right? So B, is everybody cool with B? Is definitely 10 plus extra bits. How do you represent the extra bits? What do I know about this triangle? This do this triangle here. Right? So I know this is 10. I want to know, well, let's see, how do I want to draw this? There's got to be a better way. Oh, well, this is 10. So I can do this triangle, this is 10. I can figure this out. This is nifty. In this triangle here, what is this angle?
90 minutes later.
Yeah. So then what's this angle here? Theta. I love it. Let me see. Let me think about this for a second. Oh, I see what I'm doing wrong. Yeah, so that's been lifted. So this is 10, and then it's been lifted. Oh, okay. I'm being silly. 11. So somebody help me out. What is this? This is 10. Just had to remind myself that's not an unknown. I took that 10 centimeters and I bent it up. Right? So that's 10. I know this is theta. That's like internal angles, right? And I want to know what this is. Right? I want to know what that is. So then I just have to use what? I want to know what this little bit is here. So what's that going to be? So I've got, this is 10, this is theta. I want to know what this is. So what relates this side to this side? What trig function relates those? Cosine, right? This is the x piece, this is the hypotenuse. So isn't cosine theta equal to, we'll just call this x. X over, what, 10. So what's that little bit then? 10 cosine theta. And the funny thing is, the way I look at trig, cosine, this is not exactly true, but cosine is like the percentage of the hypotenuse that lies in the x direction. So, and this is not perfect, but I don't care. So it's sort of like that percentage of 10 lies in the x direction. It's not really a percentage because cosine is not a linear function, but I don't care. It's a nice kind of quick way to remember what's going on. So what is this whole distance then? What is this whole distance then?
B equals 20 cosine.
Yeah. 10, I want to know what B is. B is 10 plus 2 of these.
So 10 plus 20 cosine theta.
Now again, the problem you're going to get is not going to be this one. Actually, your teacher might give you exactly this one, in which case you are. But you're not going to get exactly this problem more than likely. So what's more important is, what are the things I need to accomplish, right? I need to capture everything they've told me. I need to figure out what function I need to create. And I got to keep in mind what is the important variables, right? So B is not the important variable. I need theta. It wants to know about theta. So now my area function is going to be 1/2 10 plus 10 plus 20 cosine theta times h. Now can we figure out the height? Wouldn't that just be, you can do it. If this is 10 cosine theta, the height must be, if this is 10 cosine theta, because it's in the x direction, the height must be 10 sine theta. And of course, I mean, how do I know right here this is not quite where I want to be? How many variables is area a function of right now? 2. So I need to get that written in terms of theta, so I just have one variable. The variable that they asked me about, right? So then I finally get, let's see, let's bring the 1/2 in. I get 5, bring the 1/2 in, 10 plus 10 is 20, divided by 2 is 10, plus 10 cosine theta, times 10 sine theta. So again, I can't stress this enough. Any individual problem we do doesn't matter. Any individual problem we do does not matter. What matters is what made me do everything I did, right? Because that's what that's the same motivation you should have when you do whatever problem I throw at you, or whoever is going to give you that. So now I can, let's see, let's multiply this in. I get 100 sine theta plus 100 cosine theta sine theta. And then what do I want to do with that? I could, but what do I want to do with that function? What is this a function for? The area, it's not the maximum yet. This is the function of the area for any angle, right? I want to maximize the area, so I'm going to do what to this?
Take a derivative.
Take a derivative. There you go. Alright. The AD theta, I'm just going to do this real quick. 10 cosine theta, plus I've got you could kind of rewrite the, but listen up. This will just be a, what do you call it? Product rule here. So it'll be minus 10 sine squared plus 10 cosine squared. I don't know if you guys see that, right? Derivative of cosine is negative sine. Oh, that's 100, Jeff.
Yeah, I was gonna say.
All right.
I was like, oh.
Where did I go to 10?
So that's 100 sine theta sine, negative sine theta, so it's minus 100 sine squared. And then it's 100 cosine theta times cosine theta, so plus 100 cosine squared theta.
Wait, that first cosine, that's 10 cosine theta?
Yes. I think, 100, sorry.
Right.
I keep looking at those like 10s, I'm sorry. And now, of course, you want to make this equal 0. So is it pretty cool if I make this equal to 0, I just divide by 100?
Yes.
All right, that's part of the reason why I didn't care about that. Now, is this anybody's worst nightmare up here?
It's just cosine theta minus 1 cosine. Wait,
Good try. I love
Wait
it.
a minute.
I love the optimism. Love the optimism. But no.
And then sine squared minus 1, or no.
Or you can break it up.
Isn't it sine squared plus cosine squared?
Oh, the cosine squared theta, make it a 1 minus sine squared.
Problem is that's negative, right? So that won't work.
Is it a 1 minus sine squared? Is it the,
Yeah.
So change, maybe you can change sine squared to 1 minus cosine squared? And see what happens, right? Yes? Yes? Isn't sine squared 1 minus cosine squared?
Oh.
So is this going to necessarily help us out? Let's see. I'll get negative cosine squared plus cosine. So that's 2 cosine squared plus cosine minus 1. So this is good. Look, guys, this is taking too long. I don't want to focus too much on this, but one thing we used to do back in the day is this. Cosine is just C, and then it makes it easier to look at. Can I factor this?
Yes.
Yeah, let's try it. So it'll definitely be 1 and 1. I want this to be plus, so the thing that will be 2 needs to be positive. Right? Is that cool? I love you guys so much. All right. Even those of you I don't know much about. Okay. This equals 0. So either, see if you guys are cool with this. Either cosine is 1/2, yes? Add the 1 divided by 2. So either cosine theta is 1/2, or cosine equals -1. Now think about this. Cosine theta equal -1. What angle is that? Yes, pi, which is otherwise known as degrees. 180. So that would mean I take this and I fold it. Fold it. So that is one extreme. Because remember, this doesn't give me the maximum, it gives me the extrema, possibly, right? That is obviously the absolute worst thing to do. My gutter's nowhere. I don't understand. I made theta big. All right. So that sucks. Do you understand what I just said? Your critical numbers represent maxes or mins. That is the worst situation. That is the minimum amount for this thing to hold because I made the volume 0. Good job. So where's cosine 1/2? Cosine?
It's 1/2 at, 0.
No.
Oh, wait,
Sixty,
I-
right? 30 degrees,
you got
right?
the thing.
No.
60.
60. Cosine likes x.
What's half?
So it's 1/2 further away from x, so 60 degrees, right? So theta equals pi over 3, or 60 degrees. So if I make this angle 60, that apparently is the sweet spot to make that hold the most water. But now I'm curious, I want to go Google what the actual angle is and see how close to 60 it is, because in practice, there's other considerations. Anyway, that's a little much now. All right, that was an adventure. But again, don't look at the specifics of this problem. Look at, all right, I drew a picture capturing everything they told me. I identified what I needed to know. I constructed the function they wanted me to do something with. Maximize the volume means maximize the cross-sectional area. I focused on making that function first, right? So if I say maximize the cost, and you have a perimeter function, uh-oh, not good, you gotta make it a cost function. It's gotta actually represent money. Okay, I like it. Yes?
So could we also do like maximize the line of the shape within another shape?
Sure, we'll do one more example. Let me see. I'm gonna erase this. Well, this is older.
Do you want to know the angle?
Well, it's 60.
It's not, no, for actual gutting.
Oh, yeah, sure.
A 1/4 inch of slope for every 10 feet of gutter.
Holy shit, all right. So the slope is 1/4 of an inch for every what?
10 feet of
10
gutter.
feet. All right, I'm gonna work on that in a second.
Okay.
All right.
I'll be your guidance.
You can figure out what the angle is there, but you have to do a little bit of work. Okay. Thank you, Lloyd. So, let's see. Shape within another shape. What's something we could do that's not going to be too crazy? Well, we already did that. Oh, let's do, all right. This might not be very pretty, but I want to know, given y equal 4 minus x squared in the first quadrant, what is the largest rectangle that can be inscribed in there, right? This is a this should sound familiar. They threw ellipses at us, circles, they threw all this shit at us. So I give you a parabola in the first quadrant, and I want to know the largest rectangle that can live in there. Right? So what's missing from my picture so far? A rectangle. So it doesn't matter how it looks. Not really. Now, you're probably not going to draw this, because that's obviously not right. So I'm going to put it somewhere here. What is this? Because now, okay, again, what's important is the steps. Find the area, the largest rectangle that is contained in the parabola in the first quadrant. Bam. So we draw the picture, put in some rectangle guess. Now I have to construct what function again? Area, because I have to maximize the area, right? So the area of this rectangle is length times width. So what is this? This is x. And of course this is y, which is also known as 4 minus x squared. So again, you capture what they tell you as much as you can, and then you try to construct the function for what they ask you, right? So they ask me about the area. What do I know? What do I need to know the area of this? I need to know its width and its height, right? So now what's the area? Yeah, so area is 4x minus x cubed, 11. And then of course, so this is a hell of a lot better than that last problem, right?
So this is it?
Yeah, dude.
Okay.
That one was worse because there were angles involved, and then to solve it, it was trig stuff, right? So that had a lot more going on. This one's a lot more straightforward. There's no trig stuff here.
Do we really have to like find a specific number?
What do you mean?
Oh, are we still, do we just leave it at the a equals 1 x minus x cubed? Is that it?
What? I want to know the area of the largest rectangle. I need a number answer. That is the area of every rectangle that could live in there. I don't care about the tiny ones, I want the biggest one. Right? So of course, I've given it away, but obviously we should know, now that I got the function constructed, I'll just take its derivative. And set it equal to 0. So I get a nifty thing. Add this over, divide by 3, take a square root. I get 2 over the square root of 3, which is also known as 2 rad 3 over 3. So if you circle that and keep going, are you okay? What was the question I asked? Yeah, what's the largest area? So now I just plug this into the area function, right? And I don't care. You can just do it in the calculator. So if I go 2 rad 3 over 3 out, then that would create the largest rectangle. What is this, by the way? What is this point? Can you tell me that real quick? That's the function. What is this? 2, 11. What is 2/3 rad 3? Just curious. Can somebody, 2/3 rad 3 is like 1.2, I think. 1.18.
1.73.
Damn! Is that really 2 rad 3 divided by 3? Okay.
I divided it by 2. Hold on. 1.15.
Okay, I like it. 1.15. So that lives within this, right? So it was actually more back here. I don't. You guys kind of with me? Again, this specific problem doesn't matter, right? I know I say this a lot, but what matters is why did I do each thing I did? Because that's what you need to do for whatever problem I give you, right? You draw a picture if applicable, you figure out what variables you need to get to the question, and once you got that function created, same thing. Sometimes I call this the SDT level of the problem because you do the same damn thing, right? Take the derivative, say equals 0, blah, blah. Say again?
Can you do an ellipse one, like a rectangle inscribed in an ellipse?
Maybe later. I wanna, well, if nobody else has any other things, we can do
So
that.
just to clarify, so the 2 root 3 over 3, we plug into the original A.
Good,
and-
yes.
Yeah, okay.
So you get whatever out, and that's
And
the
then that
problem.
would be the
Whatever
answer.
you get. Yeah.
Okay.
If you want a break, I'm also gonna do related rates.
Related rates, okay. So this is the one about the, I don't know why how people are so fascinated by ladders, but we just are. Ladders and grain falling into a choke chip or cone and stuff like that. So related rates was back in 3.9. Let's see. Sure, let's start off nice. Snowball melts so that its surface area where'd you go? Decreases at a rate of 1 square centimeter per something minute. So that's what they tell me. Snowball, it's melting. The surface area of the snowball is decreasing by that much. Blah, 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 blah. Find the rate at which the diameter decreases when the diameter is something. Where'd you go? There you are. 10 centimeters. 10 centimeters.
What's the original surface area of the?
That's a big ass snowball there. Yeah, that's a pretty big snowball. Okay. Are you guys okay? You guys understand that? Well, what's the first hurdle to get over here? What function do I need to exist so I can do something with it?
Oh, you need a function of axis.
I need a function of surface area, right? Because what is this in symbols?
Yeah, you're like really
What is this in symbols? All right, I like it. Something over dt, sure. Change in what per time, of course, and it just tells you. Change in surface area. So let's just call that, well, maybe I'll leave it as SA. SA. So again, what's the big thing with related rates problems? You need to give variables to the various parts, identify in calculus symbols and otherwise everything they tell you. So how do I identify what they're asking me in symbols? Now this kind of sucks. We normally call diameter D, but then you have DD. I don't know if anybody knows. So let's call diameter something else, yes? Maybe? Or are you guys okay with calling it? Let's call it capital D, is that all right? All right. So then how do I represent this, this question in symbols? DT. Okay, so identify what they tell you in symbols and identify what they ask you in symbols. Does anyone remember what the surface area of a sphere is? Here's the beautiful thing. Well, do you remember the volume of a sphere is?
Something pi.
4/3.
I love it. Something pi. 4/3 pi r cubed. If you take its derivative, you get 4 pi r squared. So I would give you this function if I gave you this problem. But the surface area of a sphere is 4 pi r cubed. No, Jeff. Squared. I'm thinking about both things at once.
So then its surface area is just 100 pi.
Say again.
Its surface area is just 100 pi.
At that
At
snapshot
10
time. But we don't care about that.
Oh.
That's the biggest mistake students make on this, is they'll put this in too early. Right? And of course this means the radius is something. But we gotta be careful here. Is this the variable I want here? No. So what's kind of implicit here is how does diameter and radius compare?
Diameter is 2 times.
So therefore r is 1/2 d. And again, why am I doing this? Because the function I have has r in it, and which variable do I really care about? The diameter.
Can you just like convert the diameter to the radius and just have like r equal 5?
But then it won't match this.
Can you just change that?
You can later, but then you have to actually use this relationship anyway. So let me do it both ways. In fact, let's do this first. Let's go ahead and do this. What's d? Now, let me see. Is everybody cool with the fact this is a relation between radius and surface area, right? So that's related values. I want a related rates because I have information about the rates of change. So of course, what do I do to that function to make it become a related rates function? I take the derivative, right? And then it's changes in time. So dsa dt equals
Pi r.
8 pi r. It's almost done. Almost done. All right, surface area is changing over time. So what's the radius doing? Is it staying constant? Isn't it changing over time? Yes? So don't you have to multiply by
Oh, yeah,
dr dt? See?
And you only do that when it's changing. Like at DRDT, when it's changing? You only-
Whenever you take a derivative, that the variables themselves are functions of them. So if I do d by dx and I have y and w and they're both functions of x, they both have to have chain rule because they're all implicit. So this is implicit. This is implicit where everything is implicit.
Okay.
Do I know surface area as a function of time? No, shit. Do I know radius as a function of time? No, shit. Right? So they do is derivative times the inside function.
Got it.
It's the same thing as implicit differentiation, which I know you're building on something students actually hate by itself, but that's the idea it's built on. Now I plug in what I know. This is what? At my snapshot time. Yeah, anytime actually. It's just 1
Yeah.
equals 8 pi. What's the radius? 5. Good. So then dr dt equals 1 over 40 pi. And what's the units?
7 meters per minute.
Centimeters per minute. Does that answer the question? Nope. Nope. Yes?
Real quick, just because I think I'm overthinking it. So the D equals 10 centimeters, that's our capital D, right? Like, where it says.
Yes.
Okay, so
I'm
then
sorry.
just plug
Yeah.
it in and then.
I changed it to big D later and then I forgot that.
Sorry, I love overthinking stuff.
You're good. You're good. So then that's not the answer. You guys understand? I didn't answer the question because we got the question right here. But we didn't answer this question, did we? All right. But I have this relationship, don't I? So then I can do this is equal to 2 this. So this, is that cool? I mean, this is the way you wanted to do it, so I'm just doing what you wanted. This is equal to twice this, so then it's actually going to be 1/20th pi. Or I could have put 1/2 d in there, simplified derivatives, and then gotten this answer directly. Either way, it's pretty much the same word. Math doesn't care.
Why is R equal to
R equals, say again?
When you substituted, to R, because that's the diameter, you
Yes.
used 2 dr.
And then I took the derivative,
Why'd you substitute dr over dt for R? Where,
I-
where'd you get that? I'm sorry.
Why is there a dt here?
Because that's the change.
Because I taken the derivative.
Yeah.
What's the derivative of R?
Oh,
Yeah.
got it.
Okay.
Listen.
I didn't substitute anything, I just took derivatives.
Oh.
Yeah. It may, there's some concern.
Wait, I
Whoops.
lost you with from 1 over 40 pi to 1 over 25.
Oh, so this is twice that, yes?
Yeah. Oh, is that what R, because R was 1/2?
No. Diameter is twice R.
Yeah.
So then the change in diameter is twice the change in the radius.
And that's where you, okay.
Change in radius is 1 over 40, so change in diameter is 1 over 20.
Multiply, okay.
Yeah. And the reason that is because the radius is on both sides. So each radius changes, so then the diameter changes twice that. Does that make sense? I mean, that's just, you don't even have to think about it calculus wise. Whatever the radius is doing, it's doing it twice because it's on both sides, yes? So the whole diameter will be twice what the radius is doing. I don't know if that makes sense. Because it takes 2 radii to make 1 diameter. Okay. Maybe. All right, you guys are unsatisfied. I'm sorry. But again, I can't say this enough. Every individual problem we do, none of them matter. What matters is what I did, or what we do, and why we did it. Because that's what you need to know for the thing I'm going to give you. Who knows what I'm going to give you?
Can you give us nothing and give us all an A?
I could. I totally could. But I'm not going to.
So it's a choice.
Still my choice. That's right. But I'm evil. I got an A++ in my evil class.
What was your professor, Dr. Benchmarks?
No. We were talking. All right, what's next? Anything? We got some time left. What's anybody have a request?
Sorry.
And you guys look shell shocked.
I'm just confirming, so on the right, second to bottom step, the 1 equals 8 pi, so that's the same thing as like implicit when you do like R times
Well,
R.
this to this was implicit,
Okay,
and then I'm just plugging stuff in. I know
Oh,
that's
so-
1. I know that's 5.
it's like if you did like R times R prime, but you just substitute
Yeah,
for
yeah,
R prime. Okay, okay, alright, good, okay.
I like. Have I overwhelmed you?
Moment.
You asked for
It's like forgetting.
it. Any? Yes.
Because with related rates, like it's always difficult knowing when to put stuff into the equation.
True.
I always have trouble, I put.
This is why when we did
constant-
this, and I should have done it up here, but you identify the snapshot, right?
Yeah.
Does it make sense when I say snapshot? There's going to be at a time when, oh, you go, oh, okay, that snapshot shit, I don't put that in yet. Because if you put that in too early, all the derivatives are 0, and you're just sitting there staring at your paper like,
What I do.
Guess it's 0. But no, you put the constant in too early. It's changing, so it's changing, and you're just interested at a time when this is this, what's happening? So you don't put that constant in because it's not always that. It's only that at that snapshot. So you got to identify what is my snapshot information. That I'm going to put in later after I've developed a related rates equation. Yes?
Well, I have a question, if I, like, going off topic from this.
Of course, yeah,
So
we need to.
I think it's just velocity, so like in this equation, or in this example, it's talking about a ball being thrown vertically.
Doing what again?
A ball being thrown vertically up.
Sure.
And then, with like giving the velocity of 80 feet per second, and then its height after t seconds is,
8 feet per second?
8
80. So velocity is 80.
feet per second, and then
Just
its
chuck it.
height after t seconds is s equals 80t minus 16t squared.
This is what you're given?
Yeah,
And what is it again?
s equals 80t minus 16t squared.
And by the way, this is the gravitational pull. This is it's 1/2 32. It's 32 feet per second per second. That's gravity. So that's why you see 16 in a lot of these things, because gravity is acting down, so it's minus and more than you want to know.
And then it just gives, it's just asking like, maximum height the ball reached, and then the velocity after 86 feet above the ground, but we're more confused, like,
Well, wait a minute.
just
So
how
it
to
said,
go about the whole thing.
oh, this is the initial velocity, right?
Mhm.
Okay.
So like asking like
All
what
right.
its highest point is.
All right. Maximum height, easiest freaking question. It's not a calculus question. It's a parabola, find the vertex, right? It's a down parabola, so negative b over 2a. You could even do that, right?
S
Or you could do
A.
calculus. You could take this derivative, set it
That's
equal to
what I was
0.
thinking.
Sure. But since this is a parabola, pre-calc would work, right?
Oh, because then you can just put it in.
Yeah. In fact, real quick, do you guys remember negative b over 2a for the vertex? That was a shortcut to find the vertex? No? So really that's finding the answer to this. It's finding the maximum or the minimum of this, right? So in calculus, wouldn't we just do this guy's derivative? Set it equal to 0? Don't I get negative b over 2a? Right? Also, in pre-calc, you actually see this just looking at this thing, and you say, this is this plus or minus that. The vertex is in the middle, so the vertex must be here. So that's how we proved this before we knew calculus, but calculus just kind of laughs at that shit and says, what are you doing? Bam! All right, it's more than you asked, but just a little quick history. So your first question is just find the vertex, and you can just do ds dt, sure. Now when you do this, you're actually finding the what function. Take the derivative of the position function, you're finding the what function? Velocity. Which is going to help in your second question. What is the derivative of this? And then you can set that equal to 0, and you blah, blah, blah.
And then you just plug that in.
Now what's it, so the first question was,
Its max height.
all right, it's max height, yeah. So you're going to find the time, and you just plug it in to figure out its height, right? What's up?
I'm overthinking it, hold on.
You are. What does this function do? It tells you where it is.
Yes. and
We're going to
then-
get a time. We want to know where it is,
So get the velocity.
so we plug it in here.
What do we plug?
That first question
Oh,
says,
yeah.
how high is it, right?
Mhm.
Once I set this equal to 0, I'll get a time.
Oh,
I
and
plug
then
that
you plug
into
it
the
back in.
position function because that's what it wants to know. What's its position? Yeah.
Okay, yeah.
Now the second question was,
Asking what the velocity is when it's 96 feet above the ground.
oh, 96 feet above the ground. Which equation up here relates to that?
Isn't that the acceleration?
No.
No, that's.
No. It's 96 feet above the ground. Isn't that telling me where it is? Which function does that? Position. So you make this 96. Solve for t. Plug it in here. Yes? You guys see that? 96 is the position. Solve for t. Plug it in here. You're going to get 2 times. Is that cool? So it wants to know the velocity at a time when the position is 96. All right, so this is a 2-step problem. Because I can get the time from here, then I can plug it into the velocity function to see how fast it's going. Maybe? No? Yes.
So it's just identifying what function does what.
Yes.
Separating it.
Yes.
Okay.
Yes.
So 1996 put it into position. And then.
Yeah, so how would you do this?
Got it correctly.
I think 16 goes in everything, does it? Yeah. That's nice.
Oh, but then, yeah, then you pull out.
Here, dear God, if you have a number there, just see if it divides.
And then you just factor it.
Factor
which
it.
is T6 and 1. Agreed to.
Well, you gotta be positive, so they have to have the same sign, right?
Yeah.
Okay. So 2 seconds and 3 seconds. And why does that make sense? Because on the way up, it's at 96, and on the way down, it's at 96. That's why there's 2 answers. So then you have to put a 2 in and a 3 in.
And then you have 2 answers?
Yeah, the funny thing is, one of them will be positive number, the other one's gonna be negative that same number.
Oh, because it goes,
It makes
yeah.
sense, because it loses that speed and then it picks up the same amount. So if it's 80 here, it's gonna be negative 80 there. And that might be the point of the problem, just to remind you of that. Yeah?
But then doesn't it depend on like, what is negative and what's positive? It's like.
Yeah, and they've identified, since this is negative and this is gravity, they've identified down as negative. So that's why on this side, it would be negative, because now it's coming down. I like it.
Okay, yeah, that reminds me of, there was a question you helped me with once where I was confused of f of x and g of x.
Yes.
And talking about how above the graph, when it's going down, that means it's coming.
Yes.
It's not the English. Going up means it's moving forward, going down means it's going
Yes.
backwards, yeah.
All right, depending on what that graph was, yeah.
Yeah.
Yeah, yeah.
Sorry, I was thinking of it now.
Okay.
So the 80 per second and the 80 minus 32 t are the same thing?
Say again?
The 80 feet per second and the 80 minus 32 t are the same thing?
No.
They're both velocity.
All right, so
Like
this is
same
the
problem.
initial velocity.
Oh, okay.
So watch this, at t0, what's velocity? 80. There you go.
Oh.
So they really didn't have to tell me this.
Okay.
But the initial velocity goes here in front of t and the position function then.
Okay. Alright.
Yeah.
So we do like you said like for the
Yeah.
test.
All right, so we're gonna do a U sub problem. Not a U sub problem, but a U sub problem.
No, you suck.
Tomas is testing the boundaries. All right.
Oh, not you. I mean, you suck.
I'm like, let me remember that, Thomas. When I'm grading your final.
I'm not talking about you, Mr. Will. I'm talking about you suck. I don't like it.
Understood.
What? How do you not like these institutions? So look at what's helpful in the world.
There you go. Love it.
You are fake.
All right, now, guys, tell me. Guys,
I would work as friends all the time.
Sorry.
everybody, shut. Do I need U sub for this problem here?
No.
Nope.
Phone
Can you just make x to the 1/2 distribute? All right. So screw that. Let's do one like. Do I need U sub for this problem here? Yes, do you see? Because now I got more than one term inside the radical. It's not gonna, I can't distribute that to x, so it sucks. So obviously, what are you gonna let u equal here? X squared minus 3. And then du is?
Oh.
Du. And this is interesting because U sub is an example of somebody having trouble with manual transmission, right? So you gotta go reverse, right? So you're thinking integrate, but in this step I gotta differentiate. So I can hear the gears and I see the smoke. This is 2x dx. Now, some of your crazy ass instructors, hey guys, they teach this in a really silly way. I'm really sorry. You shouldn't solve for dx, that is complete bullshit. But, I mean, if your teacher wants you to do it, you should do it. Okay. But, do I have what I need for du? I have x dx. What am I missing?
Divide by 2.
I'm missing a 2, so I'm going to put a 2 in, and I'm going to put a 1/2 out. So overall, I didn't do anything. No need to solve for dx, no need to set myself up for stupid mistakes. Just construct what you need, right? So if I'm missing a constant, that is no problem. If I'm missing a variable, if that x wasn't there, I'm screwed. I can't do it. Okay, so I get 1/2 integral. What is 2x dx? du. And how do I write this? Yeah, u to the 1/2. I love it. And I told my students, I wish we had never come up with radical notation. It's dumb. You should have just used exponents, but too bad for all of us. What's that integral?
1/3 u to the 3/2 when you multiply 1/2 with it.
Oh, I see.
Yeah.
Now, this will be u to the 3/2, so you put the reciprocal out front. So there'll be 1/3 u. Oh, I left that. Oh, no, there it is. So 3/2 plus. All right, that was a nice, straightforward one, right?
Could you do one where like there's something disgusting on top of the other? Like
Something-
like 3/6 or something?
That's so bad.
Do what now? Sorry.
Like the one from the test?
What was that one?
That was integral of 5 natural log 6.
Oh yeah.
Yeah.
Oh yeah. Okay. That was a fun one. Yeah, let's do that one. Why not? What was it from?
It was e.
Down here was e.
Oh no, down there was negative 1/3, and then on top was e minus 3/6.
Oh yeah, that's right. So this was a test problem I gave my students, and they were all like, "Oh, thank you, Mr. Orman, so awesome." So here's the thing. You start u sub by saying, as a teacher, we say, find the inside function, let u equal that. And I try to let my students know that's not always going to be it. That's the basic kind of u sub. The real general idea is let u equal the thing whose derivative is in there also. Most of the time, that's like an inside function with an outside check. But here, the inside function is like 6y plus 3, and its derivative is not necessarily linear. It doesn't really help me. I've got this other stuff. So what do I want to let u equal here then?
Natural log.
Yeah, I want to let u equal natural log, because then the derivative would be 1 over y shit, and that seems like maybe it'll match, right? So if I let u equal natural log of 6y plus 3, what is du?
6 over 6y
1 over 6y plus 3 times?
6y plus 2.
Times 6, yes? Derivative of the inside. So if I reduce that, I get 3 goes into everything, yes? Do I have what part of that do I have in there already? Yeah, I got the 2y plus 1 on the bottom, beautiful. So I just need a 2 on the top. So I'm going to multiply the top by 2. In fact, I can take that 5 out because it's just in my way. I can put a 2 here because I need that for du, which means I need an over 2 out there. It's just a better way. I don't know if you guys solve for dy or whatever, but you really, I'm sorry. It's a disagreement, but it's okay. You could do it, but it just leads to mistakes. What do I do with these guys?
You gotta put them into what u equals to find.
Yeah, because right now, this is what y is doing. So when I set up my new integral, this will be du, and this will be u. Damn, that looks good. But, so this is what this variable is doing. So I can't put these numbers here because it's not what u is doing. What do u be doing? So if y is negative 1/3, u would be negative 2 plus 3, 1, natural log of 1 is 0. If u is e minus 3, I'm sorry, if y is e minus 3 over 6, then this will be natural log of e, which is 1. Now that kick so much ass. Here's where we were, and here's where we are. Damn straight. So what you said, completely right. I mean, that's too beautiful. Without u sub, we couldn't do that at all. Or it would be really hard. What's the integral of u? No.
U squared over 2.
Oh.
0 to 1? Yeah, you just over things. It's not 1 over u. Part of your brain was like, it can't be that easy. And then you just plug a 1 in, the 0 makes it 0, so you get 5/4. So there's a freebie for my students for a correction you can make if you need to.
So you got the 0 to 1 by plugging
Yeah.
in those into the.
So when y is negative 1/3, u is this, which is 0. When y is e minus 3 over 6, u is this, which is natural log e 1. And again, this, when you do disks and shells, you start to really appreciate how important this is. Because this sets up everything. If it's disks, maybe it has to be dx, which means all this has to be x, which means these have to be what x does, right? So right now, that's dy, this is what y does. That's du, these have to be what u does. And u doesn't do the same thing y does, because u is freaky shit with y, right? So you gotta figure out what's u actually doing. What is u actually doing? My grammar gets bad when we get to this part. What's up, Carter?
I was just.
Okay.
You're good.
Try to read your eyes. I see a lot of this. That's better than this.
Yeah.
Get that a lot.
That'll be doing really good.
Oh, like, especially with those angles, I'm like, okay.
Woo! All right. So again, so next week, of course, Monday's a holiday. Are we in this class, my class, are we in this class next week? No, I know I've said that several times. All right, and then Monday, the final actually starts a little later for us. That's good, 9:25. You've got my office hours for finals week, right? Hold on. Oh, okay. Updated one of these. You gotta read it. Oh shit! Do you want the answer key for the practice final?
Yes.
Yes.
Yeah, Wednesday, right? Because they're closed on Wednesday. Oh, yeah. Yeah. So, Wednesday.
I know, I looked at it, I just put it away. Like I'm gonna overrule myself.
Yeah, see, 2y plus 1 here, right? Which is divided by 3 everyone? That's why. And I just need a 2. So we took the 5 that was here out, and then I put a 2, which meant I had to put it over 2 to balance.
Oh, that was a 5 right here, okay. I thought
Yeah, that was a 5.
I misread it, okay, that makes sense.
So I had a 5 first, and then I erased it and put it
And then
outside.
you did 2 because
Yeah.
we brought it to that, okay, that makes sense.
Sure. And you guys can see in terms of handwriting, you probably chose well in terms of which teacher. First day of class, I'm normally apologizing about. You've chosen poorly if you wanted to be able to read anything, all right? Yes?
So for 2a, it says fx equals 3 ln x minus x times x plus 4.
Yeah, what was the...
For this, it says 2a is ln x squared minus x cubed.
Of course, yeah, sure, of course. Holy shit.
They're-
Yes. What do you do? Guys, if I ask you to integrate or differentiate a function, what do you try to do first? If I ask you to integrate or differentiate a function, what do you try to do first? You try to simplify it. What can I do with natural logs? Can I take that down? Yes? Yes?
Yeah.
And then can't I factor the inside? And then can't I do natural log of this times this is natural log of this plus natural log of this? Now the derivative will be easy. The derivative of this would suck. Big time. The derivative of this is easy shit. Maybe? Is that right? So I just did log properties. You don't have to do log properties. You can do this if you want to. I'm not going to stop you. I don't understand you, but I'm going to do it. So you always try to stop and think, can I simplify this function? Especially if it's like a rational function. Maybe you can factor and kill something, right?
If you were doing the derivative way, it would be 1 over x squared.
If you're doing the derivative immediately,
Yeah.
is that what you're saying? Yeah. It would be 1 over this times the derivative of this.
Yeah.
Okay.
Okay.
That's gross. This, I'm done in one step, right? The derivative of this would be 3 over x plus 3 over x minus 1. Thank you. Bye. I'm out. This will become that after a lot of work.
Because you wouldn't let us just put the thing
Yes.
on top of the fraction.
Say again?
We couldn't just like put the derivative of x squared minus.
Well, let's see, yeah, this will be 3x squared minus
Oh,
x squared times 2x minus 1 over x squared minus x cubed. You can see right there, these cancel. 2 of these cancel. Now, to be honest, if you do this, you don't have to break it up.
Yeah.
You'll just get, the answer you get will be this put together. Yeah.
And also, do you have the Newton's method handout like on Canvas?
So what now?
The Newton's method handout that you made? Is it
Oh,
on Canvas?
I don't think so. I mean, if you email me, I could just send it to you. Yeah.
Oh, yeah, if you want, I actually
I forgot.
got a pretty cool trick you
Hold on
can
a
do
second.
with your calculator that's just, you can do it for any function. I haven't put it in first.
Do it again.
So there's a pretty neat trick I found on my calculator that I can do for like any method. So if you go to the stat plot, go to the stat plot, you write the function and the derivative of the function. Then you go to you like clear out of that. You put like your first guess, press the stow button as it gets closer. Like
So here's the problem. On a Newton's method problem, what's the work I want to see? Is I want to see the Newton's method set up. If you don't show me that at any time, you're going to lose
Yeah, this is
a
just
decent chunk of points. But that's an idea. You found a way to check your work out. Well, the check your work, you just do that, right?
yeah.
Yeah.
It's just it takes less time.
Well, yeah,
That's the only reason.
because you're doing less of the work yourself. All right, guys. So maybe I'll see you next week. Otherwise, I'll see you a week from Monday. Have a good long weekend.
Are you gonna be at the math lab Tuesday, Wednesday?
Yeah. If you want, I mean, here's my schedule for Tuesday. I'll be 10 to 12:30.
10 to 12, okay.
Wednesday, I'll be 10 to 12:30.
Alright.
And Thursday, I'll be 9:30 to 10:30.
So our final, what day do you guys do your final?
The last day, Monday the 6th.
We
Yeah.
do ours on the 2nd,
Oh yeah.
so,
Get it done quick.
yeah.
I noticed that on my grade sheet, you said that I can do turn in test corrections for just 3.
Isaac, right?
Yeah,
Yeah. Anything you haven't corrected, you can still turn in.
okay.
Just the later it is, the less points you could get back. But if you get enough right, you should get some points back.
And what do we do about when you
Yeah.
want to
Yeah.
see just the work redone?
Yeah, you turn in the original, and you can do the corrections on another sheet of paper.
Okay.
Kabam.
And then in terms of homework, should I just try to do as many as I can? Or?
Yeah, it's up to you. I mean, as much as you can get done,
Yeah.
that'll push you closer to this, so like that would push you closer to this,
Yeah.
which would push you closer to needing this to pass, right? Yeah, so I mean, plus it'll be practice.
Yeah,
So,
exactly.
in terms of your grade, corrections are big, right?
Okay.
And then in terms of getting ready to final, homework would be big.
Yeah.
So it's kind of like a balance between those.
Yeah. I just have a final today, so I'll be focusing on that. Then
Today?
Yeah.
Damn,
Computer
that's
science.
illegal, that's all right.
But yeah, after that, I'll have the whole week to kind of go through everything.
Gotcha.
Awesome. Thank you.
Sure.
Appreciate it.
With the
let's see what happened here. Oh, what happened, what it should be right here is a 4. Because I didn't know where that 1/2 was coming
But
from.
I thought, like, cause you know how with our discs and shells, we leave the constant all the way out to.
Of course, totally,
Yeah.
totally.
So
What's
I
the
figured
interval?
we
No,
could-
no. What's the interval of U?
U squared over 2.
Ah, so there should be an over 2, and that 2 is already there. So that should be a 4 already.
Before you even integrate it, before you even, evaluate from 1 to 0.
Yes, yes.
Okay, I got you.
Yeah.
Is it still up here?
No. But I had 5/2 times 1/2
Yeah.
U to the second power. So that was 5/4 U squared, which is what this should be.
Okay.
So I was just like, where did this guy come from? It should be, and I didn't realize he didn't have a 4 there already.
Yeah, but that gets you 5/4, right? I know.
Yes, but
Okay.
tell me where the 1/2 came from.
I got you.
All right. All right. Bum, 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 bum. Bum, 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 bum. All right. Yes. All the people that really, really needed to be here were not here. Oh well. Yep, you heard me.